Hello all, this is Srinidhi here, and in this particular video we'll be studying some few basic introductory part for the subject of analog and digital electronics. So in this particular video we have some prerequisite, we have a checklist to be covered in this particular video that we'll be covering during this video. The very first thing is when you hear the subject called as analog and digital electronics, there are two main words are there. One is analog and one is digital. As you see the meaning of analog means somewhat it is like continuous in nature, and discrete means digital means discrete in nature. So an example for analog can be a human voice in air, or a temperature in a thermometer is an analog in nature. Digital means it is divided, a digital calculator or a digital signal which is generated. Okay, so an analog, if you consider for a graph, analog is continuous in nature, a sine wave. Digital is discrete in nature. So this is the basic difference of analog and digital. Keeping in this mind, so we shall see what are all the concepts that can be covered in this video. See, first thing is, why studying this subject? What is the importance of you people studying this particular subject? See, studying this particular subject plays a vital role. It acts as a fundamental when you study the concept of microprocessors or microcontrollers in your further semester or anywhere. So this particular subject acts as a fundamental basis to the whole subject. Next we need to know what is the history behind this subject. Coming to the history point of view, I'll not be going about where exactly, which year, which and all started. So basically your computer is an electronic device. Within a computer it has the motherboard, which is the main unit. So in that motherboard, that particular motherboard will be consisting of n number of circuits which will be placed on a motherboard. So who is responsible for the digital designing of that particular circuits? What is the agenda behind that particular circuits, or how exactly that particular circuits have been designed? Is it curious, right? So the answer comes here, that particular circuits we call it as a digital circuits. So this is where we start building the digital circuit. This is what the small history of the digital circuit and the importance of knowing this particular digital circuits. So this covers both the history as well as the importance. Coming to the prerequisite of this particular subjects, you have studied the basic electronics in your lower semester or outside that particular subject. There are few things which you need to know. Have a quick glance of basic electronic subjects as a prerequisite. And for this subject, so it deals with digital logic. Please go through the Boolean laws and Boolean variables in which we'll be solving a number of problems. So it acts as a prerequisite for this subject. So Boolean laws is, I'll write it here. So Boolean laws, you need to know. Okay. Apart from Boolean laws, you need to know the logic gates. Okay. So in this particular video, I'll not be discussing about Boolean laws. I'll be making a separate video exclusively for Boolean laws. But in this video, I'll be discussing about this logic gates. That is one thing. Next thing is, what is the syllabus that we are going to cover? See, when it comes to the syllabus point of view, you have about 5 modules, in which the first module is a theoretical module where we'll be studying about the electronic devices and its components and working principle, advantage, disadvantage and its application part. Whereas the rest 4 modules, starting from the second, third, fourth and fifth module, completely deals with the problematic part. There are a number of, it's a mixture of both problems as well as theoretical concepts, I would like to say. Okay, so it covers how syllabus point of view, that is 4 modules, approximately, I don't tell it as 4 modules. Some part of the concepts require about problematic statements, and few concepts can be explained in a theoretical manner. Next is how theoretical knowledge is applied in lab. So what are all the concepts which you study in this subject? You will be start applying the same concept when it comes to your lab part. That is designing of circuit, testing of circuits, construction of circuits. Okay, these are all comes in the where your theoretical knowledge will be applied in your lab part. So any circuit starting with a Boolean algebra, a Boolean equation, then deriving that particular expression, getting a circuit, designing a circuit, and then you apply that particular circuit when it comes to your lab part. So let the concept be very clear. So theory is not like you leave the theory there and there itself and then you jump towards lab. The same theoretical knowledge, whatever you have, you will be start applying that particular knowledge when it comes to your lab part. I hope so the concept is very much clear and crystal clear. So we shall try to have a quick recap of all the fundamentals of digital logic here. So digital logic, as the word tells that digital logic. See, when you hear the word digital, there can be only combination of two things. One is either 0 or 1. We also call 0 as a low signal or 1 as a high signal. In both the logic, we'll be explaining you the concept of positive logic and negative logic also. Okay, it's not. I am not meaning that 0 is called as always. It is called as low. Okay, and 1 is called as high. Okay, 0 and 1. That is either a signal can be in a low state or in a high state. So the combination or the mixture of these combinations of zeros and ones, we try to build a logic called as a digital logic. So the whole digital logic deals with only zeros and ones. Let the concept be very much clear. Let it be very much crystal clear. From here onwards, anything we discuss is of only what? Zeros and ones. Fine? Okay, fine. Next thing. So we shall try to discuss the logic gates. First of all, I would like to ask you is, what do you mean by logic gate? Gate is an electronic circuit. I'll be defining there and there itself. You can just note down over there. Gate is an electronic circuit which accepts one or more inputs and produces one output. Okay. As you hear the word logic gates, we need to know what are all the types of logic gates that we have that will be knowing. See, logic gates is being, I would not like to tell it has been classified. Your logic gates consist of two types. One is basic gates and second is derived gates. So what do you mean by basic gates? The gates which are used to derive n number of another gates, we call it as basic gates. So for example, for basic gates we have NOT, and OR. These three gates are also called as, I would like to tell, it is not gate, it can be called as circuit also. So these three gates are called as basic gates. So what do you mean by derived gate? From the existing gates, with the combination of two basic gates, I can construct n number of few more gates, which we call it as a derived gate. Is the concept clear? Please look at, please have your concentration here. Basic gates, what do you mean by derived gate? From the existing gates, if you are applying or if you are combining two basic gates, then it formulates as your derived gate. For example, we have NAND, that is a possible combination of AND and NOT. We have NOR, which is a possible combination of OR and NOT. Likewise, we'll be studying about n number of gates. Okay. So here in this board, as you can see, please don't make your mind very much clumsy. Let's go in a simple and smooth way. See, I have represented your gates in various different manners. Okay. So here I'll be naming each and every manner. Afterwards, we'll be studying